So let's actually talk about doing some data processing. We just looked at the basics of loops. Now I want to do some data processing loops. I want to do something a little bit more interesting. Let's say we have a list of prime numbers. Prime numbers are numbers that are only divisible by themselves in 1. So I have a list of primes, small list of primes. And I want to calculate the product of the prime numbers. And what does the product mean? I'm going to store in some variable called prod. And we did something like this previously, where you would just multiply the first element times the second element times the third element, and eventually times the fourth element. I think we did summation or something last time, but the point is the same, right? What am I going to get? I'm going to get 2 times 3 times 5 times 7. I mean, that's what it's going to do. Okay, that's good. So we just multiply all those indices, those numbers with their indices together. And that works great if there's only 4 numbers in the list. Sure. What if there's 400 numbers in the list? How long do you think it would take you to copy paste primes bracket something to get from 0 to 399? I'm thinking longer than you ever want to spend copying and pasting. What if there's 4,000 numbers in the list? I think you can see at that point that's just not going to work, right? We just can't write that as code. And so we need to think of a different way of doing this. Well, we said we could do this with a loop. We said that loops allow us to repeat code, and maybe we can simplify this. So we want to be able to write this in a more generic way. And let's think about how we would normally do this. I don't think I would really do in my head 2 times 3 times 5 times 7. That's not what I would do in my head. So to do this as a human, I would multiply the first 2 numbers. And I'm going to make myself some space just because I need it. So 2 times 3 equals 6, right? And then I'm going to take the answer of that. And I'm going to multiply that by the next number, which is 5. And I get 30. And I'm going to take the last number, that 30, multiply by the last number, and I'm going to get 210. And there's my answer. This is the thing I'm looking for. This is my results. That's the answer. Great. But, okay, that worked for 4 numbers. Now I have to turn this code so I can do this for 400 numbers. And to think about, a generic or a generalized way of doing this, we have to kind of figure out the pattern. And to see what's going on in this pattern, we have to then write code for that pattern. Well, what if, remember, this is going to be our product. So we can actually say this is some product variable. So we have some product, right? So everything on the right-hand side, that's going to be in the product variable. It's going to eventually have our 210 as an answer. And then we have to think about what's actually happening here when we're doing this. So when I get the 6, I take that 6 and I use it, and then I get 30. And then I get the 30, and I take the 30, and I use the 30 and multiply that by the next number to get 7. Kind of seeing a little bit of a pattern here. We take that product, we move it over, and we use it in the multiplication. But that's only 3 multiplications or 4 numbers in the list. So what if we generalize this a little bit more? So what number is going to fill in there? If I extend that pattern up here, what number should I put in there to actually fit the same pattern? Right, this is all the numbers in the list, right? These are the primes. It's called primes. This is the primes in some sort of bracket. Is this answer going to be 1? This actually was going to be 2. However, to get to To get a 2, I do need to multiply it by a 1. Remember, this 2, I'm going to come over here. But in order to get 2, I have to multiply it by 1. So that's what we're doing here, which means we actually have to start. We have to start with a 1. We multiply it by the first prime, we get 2. We take that result, multiply it by the second prime, we get 6. We take that result, multiply it by the third prime, we get 30. Take that result, multiply it by the fourth prime, we get 210. And we hit the end of our list, and so we're done. And so we're basically, we're going to multiply by that 1, which by the, multiplication identity is what it's called. We multiply by 1, we get the same number. So we can use that as a starting point. And if you think about what's on the left and what's on the right, we actually have the product in here twice. We have the product in here twice because the 2, the 6, and the 30 all got moved over for the next calculation. And so to write this in a generic way, we can think about, well, if I have the product in here twice, then I should actually declare a variable and start at 1. And from there, I can loop, right? We know about loops. All we're doing is a multiplication in loops. And we know how to write a loop now for n in primes in our colon. And then what goes inside the loop? What's the pattern I'm repeating over and over again? Well, I'm taking the product and I'm multiplying the product by the number. So I'm taking the product, which is here, multiplying it by the number inside of primes, which is actually filled in on n. So we multiply the values together, and then we're saving that answer. And unfortunately, I wrote this really poorly. And we're saving that answer. Just want to make sure I have my indentation back in product. So we take the product, multiply it by the prime, save that back in the product. And we do that repeatedly. So we do it over and over again. And so if we actually look at this code over here, and we think about how this loop is going to run, right? We could actually, by the way, draw another table like I did previously. We could draw that iteration table, and maybe we should just to see what's happening. Let's draw the iteration table. Before I write the code and show the code, which is literally written right there, we're going to have 1, 2, 3, and 4 iterations. We're going to have some value of n. We're going to have some value of product. And what's going to happen is initially product is 1. N is going to be 2. And the first iteration, we do 2 times 1. And we get 2. And product will change from 1 to 2. In the second iteration, we just bring the 2 down. And now we have n is 3. And we do 3 times 2. We get 6. And then we go to the next iteration, which bring the 6 down. And now we have 5. 5 times 6 leads to 30. Bring the 30 down. Finally, we have 7 times 30 to 10. We hit the end. We stop. And now product is 210, and we can print that out, right? So we could do, if we did that, we would get 210. That's how that would work. And if we did this in code, we need our primes. I don't know if I have primes at the moment. So primes equals 2, 3, 5, and 7. We initialize our product variable. Put n in primes, and we just multiply oops. There we go. I didn't print anything out, so we didn't see anything happen until I typed out product, but we got the right answer. But let's actually look and see what happened. Let's run this exactly again. Set this back to 1. I'm going to restart. Same loop. Oh, hold on. My brain's doing 4 things at once and forgot Python syntax. And I'm just going to abbreviate this, by the way. This means the same thing. Prod equals prod times n is the same thing. This is a shortcut for prod times equal n, which is basically unravels into prod equals prod times n. So basically saying multiply this number by myself and then reassign it back to me. And let's print out with some labels. So n equals, and we convert n to a string so we can concatenate. And then prod equals concatenate another string, and then we put in a product. And let's see, last one. And you can kind of see that it did the same thing right there, 2, 3, 5, 7. We had 2, 6, 32, 10. That's actually the same thing that happened. And yes, I could print prod, but I already know prod is 210. Oops. So you can see we actually got the same thing that I did in the table. It gave me the red answers. I could have printed it out first. In fact, that's actually not a bad thing to do, right? I could have printed it out first and did it that way. But we basically went through the loop and through each iteration, and that's what each one of these lines is an iteration. And that's what we mean by the loop. We have an iteration. So we say there's 4 iterations in this loop. And this is how we find products. Remember, and then I actually didn't grab it. Let me grab that other. There's one line that if you don't do this line properly, and that's just initializing that initial variable there. Then the whole thing, because if I just run it without reinitializing that variable, then we're going to get some bad data. So you set product equal to 1 to start with, and then each time through, we just multiply, multiply, multiply all the way through. And that's how we get that answer. Right, so we already did the table there. We got our answer, everything's there. I did it beforehand to understand how this code was going to work. And then we ran the code and we said, that's really what it's going to do. And just as a reminder, prod times equals n is the same as prod equals prod times n. The first way is a shorthand or a shortcut to write less stuff. Now, we could go a little bit further with this code, like we really wanted to see what's happening. And I'm actually kind of tired of copying and pasting it, so whoops. Let's take this code. Put it in here. Fix my indentations, and yes, you should. Remember, indentations are really important. And I want to take this first line. Oops. And I want to duplicate it. So essentially, I'm duplicating the first line. And then we'll just print out the prod. Save that. And for loop product. So we're going to basically print out the before and after. I forgot to define primes in the file, so let's go and define primes. So it didn't know what primes was. And now you can actually kind of see what it's going through here, each time through. And let me clean up, there's something missing here. Let me clean up my label a little bit, just so we can understand it, make sure everything aligns. Because right now you don't really know what's happening. So now we can see. So the first iteration, we can see how it starts. So we have 2, product is initially 1, 2 times 1 gives us 2. And then the next iteration, we have that. And so now we really are kind of matching up what's happening right there. And you can just see how, and by the way, this is a really good example of how to figure out what's going on in code. Print it out. We call those debug statements because it helps us debug a problem when we're trying to solve something that doesn't work the way it should. And each time through, we are actually seeing how it changes. And then you can see the final iteration, we had 30 multiplied by 7, and we get 210. So we can kind of walk through and see what the memory is, which, yes, I drew it, but now we can actually see it happen. And just to make sure we have that result, and I won't copy that code. That code is the same. It just has a different one extra line. That file will be there to play with if you want to see it later, but you can kind of see how every iteration walks through, how it goes from 1 to 2, 2 to 6, 6 to 30, 30 to 10. And yeah, remember when doing products and multiplication that if you start at 0, you're going to get 0 as your answer. So make sure when you're doing multiplications, you actually start at 1, and then you can multiply.